SolidWorks surfacing is a powerful tool that can be used to create a wide variety of complex 3D shapes. In this video, we'll take a look at some common surfacing use cases, as well as demonstrating some useful tips and tricks to improve your workflow. We'll begin by taking a look at an approach referred to as hybrid modelling. This approach uses both solid and surface modelling techniques in order to achieve the end result. If you're new to surfacing, this method is an easy introduction as it requires as few as one surface to get going. We'll take this simple shape as an example. Notice that the face highlighted is not flat, but rather curving in multiple directions. These more organic shapes can be difficult to create using solid features alone, but with the help of a surface, it can be done very easily, and there are multiple approaches. The first is up to surface. Up to surface is an end condition found within several of the solid features. In this example, we'll use a solid extrude. To use the up to surface, the surface must exist before the solid extrude feature is created. When in the extrude feature, choose up to surface from the end conditions drop down and then pick the surface. The next is cut with surface. This feature uses a surface as a cutting tool. The surface must fully intersect the body that is to be cut, and you can control which side of the surface that the volume should be removed from. Replace face has a similar workflow to cut with surface, but with replace face, the surface does not have to intersect the solid, although it can, like it does here. Replace face is also useful where the surface intersects the solid across multiple regions, but you only want it to affect a single face. All the methods demonstrated achieve the same results, but offer different workflows. You'll find the more you work with surfaces that it's always good to have a few different tools available to achieve the results you're after. When surfaces are created, you will notice that you can get multiple faces between different entities within the underlying sketch. Whilst this isn't necessarily a bad thing, sometimes this is undesirable and can cause issues with selection later on. Using the fit spline command will reduce the number of entities and result in a single smooth surface. Sometimes fit splines are not appropriate or possible, resulting in you having to select each element that makes up a surface when using it within a feature. This can be time consuming and can also lead to undesirable results because SolidWorks treats each selection independently. Instead, you'll want to use the selection manager to tell SolidWorks to treat the selection as a single entity. Lofts, sweeps and boundary surfaces all support it. Simply right-click and choose the selection manager and a new pop-up will appear. There are various options to it, allowing you to set loops, or simply click the appropriate edges individually and tick the green tick when done. Not only will SolidWorks now treat the selection as a single entity, the selection manager is really useful as the edges can actually be from different surfaces. Construction surfaces are those that are used to help build a model but don't actually form part of the final model. They are extremely useful, especially when wanting to control surface tangency, curvature, and include manufacturing details such as draft angle. Let's take a look at this example. There are 4 profiles that I'd like to add a boundary surface between, 2 in direction 1 and 2 in direction 2. The 2 shorter sketches have been drawn in a way that factors in a 5-degree draft angle. However, if I add the boundary surface in just using these sketches, I don't have the control to maintain that draft angle throughout the surface, and you can see that it deviates through the midsection of the boundary. Instead, let's create a construction surface. The construction surface will factor in the required 5-degree draft so that when the boundary surface is created again, the surface edge can be used instead of the sketch, and therefore tangency can be applied to control the surface. The end result is a surface which maintains that 5-degree angle throughout. In general, surfacing will result in more features than solid modelling, and often more bodies. This is because surface bodies will be created that won't end up as part of the final model. These are referred to as construction surfaces. These can be easily hidden away using hide show, but to keep the feature manager tidy, they can also be deleted. Add a delete bodies command and select either the bodies to delete or the bodies to keep. This can be done incrementally throughout the model to keep the tree looking tidy, or alternatively, you can just delete all the unused bodies at the end. When using a pure surfacing approach, it's usually required to trim surfaces back to one another, and this is done using the trim command. There are two main options when within the trim command: standard and mutual. Standard only requires one selection for the trim tool, but can include multiple bodies to trim. The trimming tool can be a surface, plane or sketch, and will trim through the intersection of the plane or surface, or the projection of a sketch. When using mutual, multiple surfaces can be selected for the trim tool or trimming surface. This will create a larger selection of trimmed pieces and is often a lot more complicated to achieve the end result. However, it is very powerful, and when used correctly, you can get the end result with fewer features. If you're just learning surfacing, creating a larger amount of trim features that utilise fewer surfaces can often be the easier way to understand what is going on. Knitting is the feature used to join multiple surface bodies together at a common edge. Often you'll be building a number of surfaces using different techniques, and then the knit command is used to join them into one surface body, potentially also turning them all into a solid at the same time. For large complex models, this is good practice to knit surfaces as you go. The last thing you want is to get to the end of a large surface model, go to knit it together, only to realise that it can't be done. So instead, knit surfaces to each other incrementally. Therefore, if there are any gaps between edges or errors, these can be addressed earlier on. As an extra tip, make sure to keep an eye on the edge colours. The edges of a solid will be black, as will the knitted edges of a surface, while the open edges of a surface will be blue. Hopefully you found this short tips and tricks video useful. Make sure to check out Cadassio for your 3D interactive instruction manuals too. You can find us at cadassio.com or on your favourite social media platforms.